part E of the solving by square roots notes is the one that previews the Pythagorean theorem from a geometry. So I have something squared plus something squared equals a third thing squared. It's just that two of those somethings are just regular numbers. So I'm going to go ahead and square those and simplify this. 3 times 3 is 9. 4 times 4 is 16. Still equal to x squared. So when we end up simplifying this and adding our like terms, you'll see that there's no leftover linear term. And by linear term, I meant like this guy who was left over. Since he's not left over in this problem, we can solve by square roots. I have the squared term on its own, so I'm going to solve by square roots. Every time you do that, you'll have, almost every time, you have your two solutions, and 25 is a perfect square. It's just a regular old 5. So plus or minus 5 is our two solutions here. When I look at f, here's where it gets confusing, and I'll show these to you. We'll go through them. Pretty sure they're not going to show up on the assessments for this class, but they are important skills to have, so we'll talk about them. So here, the issue is what is being squared. There are parentheses, and it's a whole expression, x minus 3. Now, it's possible to solve this by factoring. So it's possible to do this a way that we're not going to talk about during summer school. But instead, let's solve by square roots. We know the opposite of squaring something is to square root. So if this said y squared equals 1, we'd say, well, the opposite of squaring is to take the square root. And we'd say, okay, hey, look, that canceled out. The square root of 1 is 1, but you'd have a positive and a negative because you almost always have those two solutions. The issue is it's not a y. Let me actually just use that. That's not what I want. Let me use a highlighter. Instead of this y, that's not what I wanted to do. Instead of this y here, it's actually all this jazz. But everything else works the same. The first thing we do is, well, the only thing we could do is to get rid of that squared. So I'm going to start by square rooting both sides, because square rooting cancels out a squared. And just like here, where that leaves me with the stuff inside the squared, I'm going to be left with the stuff that was inside the squared. It's just that the other side of the equal sign is going to be the square root of 1. So I'm going to get the positive and the negative 1, which is a weird equation. This is saying that some number minus 3 could be 1, or some different number minus 3 could be negative 1. It gives us two different equations. So I'm going to split them up. I'm going to say that x minus 3 is 1, or x minus 3 is negative 1. I'm getting two solutions because you get two solutions when you solve by square roots. So I'm going to solve for x. I'm going to add 3 to both sides. And on this equation, I'm getting 4. But when I add 3 to both sides here, negative 1 plus 3 is not going to give me negative 4. So this is a weird one where I'm not getting plus or minus for my solution. So kind of weird. It comes up occasionally. We'll talk about them here. Don't fret too much if you are kind of lost what I did at the beginning. G is really similar. G and H are both really similar. So let's talk this through again. So what I notice is something squared. It's just that unlike here where it was just x being squared, so let's just square root to get x on its own. You have more than just x being squared. So I need to get that by itself, and the only way to get rid of a squared is to square root. So that cancels my squared, and I'm left with the stuff that had been inside the parentheses. The other side of the equal sign should be the square root of 9, which is the number 3. But remember, it's both a positive 3 and a negative 3. You get two solutions when you solve by square roots. So I'm going to get two whole different equations here. X plus 3 could be positive 3. X plus 3 could be negative 3. And so both of them will need to have negative sorry, we'll need to have 3 subtracted from both sides. One solution will give 0. When I subtract 3 here, I'm going to get negative 6. So the two solutions are 0 and negative 6. This only will happen where you don't get plus or minus the same number if you have some polynomial expression being squared. So not just regular x, but like x plus 3 or x minus 3 or x plus 20 or some expression with a plus or minus, which is what part H is. Part H, though, also throws in this 2 annoyingly out front. So I got to deal with that first. Remember when it's just written there, it's not plus, it's multiplication. So I cannot square root because there's a 2 out front. So I'm going to move the 2 by division. So that's going to still give me that parentheses of x minus 3 being squared, but now it equals 6. So now it's basically picking up where we started here. I have something being squared. The opposite of squaring a number is to square root that. So the opposite of squaring that parentheses is to square root the parentheses. So my x minus 3 drops down. 6, however, is not a perfect square, and when you look at its prime factorization, there aren't any pairs. So it's as simplified as it's going to get, but you have to consider the positive and the negative solution, which is weird. I don't care what decimal that is. No matter what I do, when I go to add this 3 to cancel that to get x by itself, that's not a like term. So again, really weird. Don't fret too much about this. Don't worry about it too much. I'm just going to say I have a positive 3 plus square root 6 and that positive 3 minus square root 6. This shows up a lot when you eventually get into completing the square in Algebra 1 and Algebra 2. It exists. Here it is. We're moving on. Ooh, except we're not moving on. That actually should be the last one, because if you are doing the assignment and we somehow don't curate it very well, if you see one that talks about graphing, you can skip that. It's important. It shows up in Algebra 1 and Algebra 2. It's not showing up in summer school. If you see word problems that use quadratics, again, very, very important. Not something in the scope of this class, which means the rest of these notes are useless. And we are finally done with Lesson 4, Solving a Quadratic by